right, we're going to look at some example problems from section 2.4. First problem here, I've already drawn on the board, is problem 2.8. And we're given this circuit, and we're told that we know IA, IB, and IC. IA is 12 milliamps, IB 8 milliamps, and IC is 9 milliamps. And we're asked to find I1, I2, and I3. So let's start by identifying some nodes. So I have a node right here. Okay, this is all one node. I have IB entering, IA leaving, and I1 leaving. Let's write an equation for that. So I have IB entering, and I1 and I1 and IA leaving. So I know sum of the entering equals sum of the leaving, and I have this equation. IB and IA are known. That means I can solve for I1, and I get minus 4 milliamps. So let's look for another node that we might be able to solve. Let's see, here we need I1, I2, I3, so that won't work. This is all one node. I can look here, keeping in mind IA comes all the way down here. So I have IA going in there. I know IA and IC, so I can find I3. I have IA entering, I3 entering, and IC leaving. Again, I have A and C, so I can solve for I3, and I get minus 3 milliamps. I need I2. Well, now I have options, right? I know IB and IC, so I can look at this node and do it there. Or I can use my I1 and I2. I1 and I3 to find that. Let's go ahead and use our IB, IC. Either will work. I have IB leaving. I have I2 leaving. I have IC entering. I know IB and IC, 8 and 9. So that gives me I2, that's a really big 2, is 1 milliamp. So let's go ahead and do a quick check right here at this node. See if our I1, I2, and I3 make sense. They sum to 0 there, or if the sum of the leaving equals the sum of the entering. So I have I2 entering that node. I have I1 entering that node. And I have I3 leaving. I2 was 1 milli. I1 negative 4, and I3 was negative 3. So yes, this turned out, so I know I've done the problem correctly. So that's a KCL example. Let's look at a KVL example. And we're going to look at one that is a little bit harder, and we'll also use our knowledge of Ohm's law. So this is practice problem 2.6. So that's in the middle of the section. And we have this circuit. A 35-volt independent voltage source, a 10-ohm resistor with some Vx across there, and a current I going this direction. Get rid of that little blob there. This is a dependent source because it's a diamond, and it's 2 Vx. So it's a voltage-controlled voltage source. I have 5 ohms here and some VO across it. And I believe we're asked to find VO. Yes. VO and Vx, I think. Okay, well, what do we do? Let's start by writing KVL. So we're going to use Kirchhoff's voltage law. I'm going to go around the circle this way and write down all my voltages, sum them to 0. Come to the minus sign first. So I have minus 35. I come to the plus Vx. Keep going, plus 2Vx. Keep going, minus V0 equals 0. So I have 3Vx minus V0 equal 35. So I have one equation and two unknowns. Obviously, that's not going to work. So we need to come up with another equation. So this current flows all the way through this circuit, right? So current I goes through every element in the circuit because there's nowhere else for it to go. There's no other branches. Everything here is in series. So all of this current is flowing through here. So I know that I can write using Ohm's law, V equals IR, I can write Vx is equal to 10I. Again, that was V equals IR. Same thing down here. That current I is flowing in here, right? But I'm entering the negative terminal. So I'm going to write V0 equals minus 5I. Again, using Ohm's law and the fact that it's entering the negative terminal, so I get a negative VI. Now I can write this equation in terms of these I's. So I have, draw a line here. I have 3 times Vx, Vx is equal to 10I, minus V0, minus 5I, equals 35. So I have 30I plus 5I, and 35I equals 35. Just doing some algebra. We have I equals 1 amp. Now that I know I can use that here and find Vx and V0. So Vx is equal to 10 times 1, 10 volts. V0 is equal to minus 5 times 1, or minus 5 volts. So it's always a good idea to check your work, right? And so we can come back up to this equation here, and let's do a quick check. 3Vx would be 3 times 10 minus VO, which we found as minus 5, is equal to 35. 30 plus 5 equals 35. Yes, using KVL, we know that we did the problem correctly.